Okay, so first of all, this is the Bellwork for December the 4th, Wednesday, December the 4th. Question number 1 is, what is acceleration? Tanner, go ahead and tell me.
The rate at which velocity changes over time.
Okay, so, and honestly, they said rate, but then they said at which velocity changes over time. The word rate implies something changing over time, so they really didn't have to, it's kind of like they said more than they needed to. So I'm just going to clean it up a little bit, and I'm going to say it's the rate at which velocity changes. I can state it another way. I can say it is a change in velocity over time. Can I represent acceleration with a formula?
Yes.
Yes, I can. Does anyone remember what the formula is for acceleration?
F equals ma.
That's going to be another one. But if I'm defining it as a change in velocity over time, then the formula that I'm currently looking for is going to involve velocity and time. So yes, ma'am. There you go. All right, so y'all make sure that you add that. Acceleration is change in velocity divided by change in time. Remember, those little triangles are just a substitute for the words change in. Okay, so acceleration is a change in velocity divided by time. And since I am going to take this eventually and just take it as a completion grade, it has to be complete, which means you have to write down, you have to have everything I have in order to get a full credit. Got it? Now, basically, number 1 is asking for the definition of acceleration. Like, what is acceleration? What is it? It's a change in velocity over time. But number 2 asks something a little bit different. Number 2 asks, what causes acceleration? Okay?
Changes in speed, direction, or both.
Yeah, but what causes things to change speed, direction, or both? Somebody said it. Unbalanced forces. That is what causes acceleration. So Tanner, what you said is basically telling me what acceleration is, but I want to know what causes it. And it's caused by unbalanced forces. Or I could say a net force. Okay, like a net force that's not equal to 0. What do I mean by net force? I have no idea, Miss Goff. It's like if you could take all of the forces acting on an object and like add them together, you get net force. Got it? Like if I have two forces acting on an object and they're equal and opposite, then the net force is 0, right? But if I have think of maybe you're trying to move a couch in your house and 2 people are both pulling in the same direction with, 100 newtons of force. They're both acting in the same direction, so you'd add them this time, and the net force would be 200. So it's like the net force is like the total amount of force once you consider all of the individual forces involved. Now, you need to keep in mind that objects will always accelerate in the direction of the net force. Okay. Now, do you guys see the difference between question number 1 and question number 2? Okay. Number 1, what is acceleration? What is the definition of acceleration? It's a change in velocity divided by time, or a change in velocity over a certain amount of time. But number 2 is asking, what is the cause? Why do things accelerate? And that's because of unbalanced forces. You guys got it? Okay. Okay. So the next question, question number 3. An object accelerates if it, raise your hand if you can tell me. Emmanuel, if it speeds up. Jacob, changes direction. Amy, slows down. Any of those 3 things or more than one of them. Okay? So an object accelerates if it speeds up, slows down, or if it changes direction. Seriously, can an object be accelerating if all it's doing is changing direction? Yes. Okay, so think about the Earth orbiting the sun, okay? What shape, approximately, is our orbit around the sun? Yeah, it's not a perfect circle, but that's beside the point. Okay, it's basically circular, okay? Which means that the Earth is always doing what? Is it speeding up? Is it slowing down? It's always changing direction. The Earth is moving at a relatively constant speed around the sun, but the reason why the Earth is accelerating is because it's constantly changing direction. What force is present to make the Earth orbit the sun? Gravity, yeah. Okay, so it's like an invisible force that can act through empty space, but it's there. Okay, so the force of gravity keeps the Earth in orbit around the sun. Okay, if I took a tin can and tied it to the end of a string, and I took that and I whirled it around in a circle over my head, is the tin can accelerating? Yes. Why? Which one of these does it? It's changing direction. It's sitting there changing direction. If I let go of the string, then I no longer apply a force and the tin can no longer moves in a circle, right? Okay. All right. Number 4. Acceleration is something you can feel. Okay. The best way I can explain this is think of yourself maybe in the passenger seat of a car. You get in the car is currently stopped. The driver hits the gas pedal, the accelerator. What happens to you when they do that? You are pushed back into the seat, right? You feel that, okay? If you're moving along and they all of a sudden hit the brakes and you slow down, you lurch forward until the seatbelt catches you. You can feel that. And if they're driving and they go around a curve real fast, you kind of lurch to the side, don't you? Again, you can feel acceleration. Acceleration is something that you can feel, okay? All right. Number 5, state Newton's first law of motion. Yes, Tanner.
An object at rest stays at rest.
And?
An object in motion tends to stay in motion.
And? He's like, ugh, I'm regretting that I spoke up. Yes, that's all true. But I'm going to crunch it down and summarize. An object is not going to change the way it's moving unless what? Unless it's acted on by an unbalanced force. Okay, which means, yes, if an object's at rest, it's going to stay at rest unless it is acted on by an unbalanced force. An object that's in motion is going to stay in motion unless it's acted on by an unbalanced force. Objects are not going to change their motion unless they're acted on by an unbalanced force. You guys got it? Okay, so let's write that down. Okay, so squeezing it down and making it as simple as possible. Objects will not change their motion unless acted on by an unbalanced force. Which means if an object is not moving, it's not going to start moving unless acted on by an unbalanced force. And if an object is moving, it's not going to change what it's doing unless acted on by an unbalanced force. You guys got it? Okay. Now, just intuitively, meaning like use your common sense, what can you tell me about heavier objects and changing their motion? Somebody said it over there. It's harder to change the motion of a heavier object, right? Okay. Now, I want you guys to be really aware of something. This says that objects will not change their motion, meaning they're not going to change their motion, change what they're doing, unless acted on by an unbalanced force. Can an object be moving and not have any unbalanced forces acting on it?
No.
What if you're... Yeah, but if you're like in a car moving at constant velocity, are you changing the way you're moving?
No.
Nope. So you can be moving without unbalanced forces acting on you. You just can't be changing the way you're moving. Does that make sense? Okay.